Okay, so these are some problems we did from section 7.5 in class. And again, this doesn't replace everything, but it might give you a little bit of extra stuff in case you're either forgot how to do it and you're just reviewing this, or you were gone today. If you have any other questions, please come in. Again, whenever I'm free before after school. But either way, here we go. So numbers 1 and 2 really are the same problem. Um, they might not feel like it, but they really are. And the key to this is recognizing that when I have two triangles and you've got either, like this case, the median, or you've got perpendicular, so altitudes, excuse me, they're similar. Okay, and they also then make similar parts of either the medians are similar or the altitudes themselves are similar. So for this problem, 10 and x are proportional because they're the parts that are going to be similar to each other. So x and 10. The key though is these little segments here, or this whole side actually, 12 and 15. So x goes to 10, 12 has to go then to 15. And now we can set up, well, we've already set up proportion. Now we can just cross multiply and solve. The easiest thing to probably do is reduce this though, and just make this 4/5. And then 5x equals 40. Divide by 5, x equals 8. So this guy here has to be 8. Okay. All right, number 2 then. Number 2. Now number 2, you might think, I don't have enough sides for this because I only have this to compare, and the 8 and the 6, I don't know if they're the same, or at least they correspond. But they do. And the reason that we do is we have two pairs of congruent angles down here, which means these are isosceles triangles. So this is 8. This guy's also isosceles, so this is 6. But again, this is an altitude because it goes from a vertex to the opposite side and it's perpendicular. Nothing else happens here. It's just we had to know these were isosceles so I can compare. So altitude to altitude, x to 9, has to equal part to part, side to side, so 8 to 6. Okay. This does reduce to become 4 to 3, so it makes it a little bit easier for us. And then just cross multiply. 3 times x is 3x. 9 times 4 is 36. Divide by 3. 12. So the altitude here is 12. Okay. So the median was 8 for number 1. The altitude was 12 for number 2. Okay. Now, next was our theorem about if you have an angle bisector and it cuts through a side. And that theorem says that these two sides are proportional to these two sides. So basically, side to its part that it's adjacent to is proportional from side to its part. So you can do 10 to 4 or 4 to 10, and then equals 15 to x, or x to, well, it depends. If I did 10 to 4, I have to do 15 to x. You could also do 4 to x equals 10 to 15. You have a bunch of different setups. So I'll just do 10 over 4, 10 to 4 equals 15 to x. Okay. Cross multiply. We get 10x equals 60. Divide by 10. X equals 6. So there we go. X is 6. Okay. Now the next one, number 5, is the same style of problem, but just a touch more difficult. They throw a little bit of a loop at us. And that's the fact that I'm going to do the same thing. Okay. Side to adjacent part is equal to side to adjacent part. And again, the only reason this works is that I have the angle bisector cutting that side. If these weren't congruent, I couldn't do that. But regardless, okay, that's what we do have. Now, the thing is, this side here is z, but the whole length is 32. So I've got to figure out what this length is. And hopefully, it seems kind of obvious if you don't know it already, that, hey, if this is z and the whole thing is 32, this guy is going to be the whole thing minus the little part here. So for instance, like if this were 10, that would mean this has to be 22, because 10 plus 22 is 32, or 32 minus 10 gives me the leftover. So this length here has to be then 32 minus z. Now the unfortunate thing about that is it makes it a little ugly to solve. But I'll show you some tricks to simplify this just a touch to make it a little bit easier for us. So 15 over z equals 9 over 32 minus z. Now, if I set it up like this, I'd be going, ugh, I got to do 15 times 32. Not a pleasant number to do. But what you can do is you can swap these. You can swap the z and the 9. You can't cancel them, but you can swap them because you'd still get z times 9. And what that gives you is then 15 over 9 equals z over 32 minus z. And that's nice because 15 and 9 reduce to become 5 and 3. And that's a heck of a lot easier to distribute now. So I'll get 3 times z equals 5 times 32 minus z. So I get 3z equals, distribute that, 160 minus 5z. Add the 5z, so we get 8z equals 160. Divide by 8, divide by 8. Z is 20. So if z is 20, that means that this has to be then 12. Okay. Now the last one I want to talk about isn't one we can really solve, but we can just argue it. Okay. I didn't put the number of this in the book, but either way, it's just an extra problem to talk about and to think about. So basically, you know, and this is to help all you baseball players out because, you know, I'm sure you do this while you're playing in the middle of the game. But if you got a batter and he hits the ball in a way such that he split the center fielder and the right fielder, and he makes it equal angles here. The question is, who should run to the ball? I mean, who's going to make the play on it? Now we're assuming that both players are the same speed, and that the directions they run doesn't dictate, you know, doesn't do something weird like, well, when he runs back, he's slower than if he runs, you know, close or whatever. So the question is, if they're both going to run, who should run to the ball? Okay, now here's the big key to this. This is the angle bisector. So let me highlight that so it stands out a little better. I've got the angle bisector. So this angle here is congruent to this angle here. So angle bisector. So my proportion is going to be 202 over, let's just call it distance 1. And a little subscript for that is d1. And this is going to be then d2. Okay, so 202 over d1 equals 197 over d2. Now that I set that up, I got to figure out which one's bigger or smaller. The bigger one means the farther distance, the smaller one means the shorter distance. Well, if these two proportions are going to be equal, or ratios are going to be equal, if this is bigger, that means d1 has to be bigger as well. So this is the longer distance, the farther distance. This distance, since this is smaller, means this has to be smaller. This is the shorter distance. So technically the right fielder should make the play on the ball because he's got a closer distance to close, or you can think of it as it's farther away from the center fielder. Again, realistically, you know, whoever's faster is going to go for it. But next time, you know, if you play baseball, you can ask your coach, well, who did it bisect? And that way I know who to attach to go for it. All right, thanks. That's section 7.5.